Imagine a car going at 5 miles per hour. How far will the car travel in 2 hours? Well, this seems pretty simple. The car will simply travel 5 times 2 or 10 miles. Notice how the speed never changes with time. Furthermore, the area under the speed versus time graph is precisely the distance traveled. Now, is this area idea a coincidence, or can we actually apply it to any graph, even with changing speed? Well, it turns out that we can use the same area idea no matter what the graph looks like. We simply need to take an approximate distance traveled in a certain time interval, which is given by the approximate speed multiplied by the time, and this is represented precisely by the width times the height of a particular rectangle in the graph. Adding all of these approximate distances traveled together, we get the total approximate distance traveled after a certain amount of time. Aha! This is a key observation. And as we make the time intervals smaller and smaller, the total approximate distance traveled becomes more and more precise. As the intervals become infinitesimally small, what does the total distance traveled look like? It looks like the area under the speed versus time graph. So this means that the area under the speed versus time graph is just the total distance traveled. If you're interested, this idea of taking areas under curves is known as integration. The other fundamental idea is essentially taking slopes at points on a curve and is known as differentiation. You just got introduced to the fundamental ideas behind calculus, or at least one of them. If change describes the world and the world is in the universe, what does this mean?